This lesson is on tangent lines, and you may be familiar with those from geometry topics that you've learned. They are lines that touch at one point, and in geometry you talked about them with a circle, and so you would have this one point called the point of tangency, which we call it that still, where the tangent line touched the circle, and so that was the definition of a tangent line. And what this lesson is going to do is take that into functions that we work with. Okay, so here's our first example. We're going to be sketching each function and a tangent line to the given point. The given point I'm going to have over here in parentheses. These functions should be variations of your toolbox functions, and so this one you have to view as a toolbox function somehow. They have this kind of backwards from what we would have learned when we were shifting. So if you rearrange these, the negative goes with the x squared and the 1 is positive. So it's the same thing as negative x squared plus 1, which means it's a parabola, it's been moved up 1, and it's been vertically flipped. So I'm just going to sketch it if that's 1. It's a parabola, something like that. I went a little wide over here, but you get the idea. The thing that we're trying to do is make a tangent line to that point where x equals 0, which is right here. And so I'm going to try to draw one of those in so that you can see. And this one's kind of simple. We can just go straight across that, and we're touching it just in that one point. And that would be the tangent line for that point. Now, if you turn it, you should be hitting more than one point. Sketching it by hand is tough. So on the actual graph, it would just touch in that one point. And at 0, that should be the top of that hill. So that tangent line should be perfectly flat, perfectly horizontal. Okay, now our second example, y equals sine x, is also a graph that you should know, and we're going to try to draw the tangent line at x equals pi. So you have to remember with sine x, the period is 2 pi. So I'm going to also mark that halfway point at pi because that's going to be important. And it goes up to 1 and down to negative 1. And then it's your sine wave, and I'm going to try to draw it as good as I can. It's kind of challenging, but again, you get the idea. And so if you were looking at one in a textbook, this is a lot smoother, but the general idea is at pi you kind of have a downhill slope. So if we want to be tangent at pi, touching in that one spot, it's going to look a lot better on a nice smooth graph than mine, but we'll insert a line and try to pull it to where it's touching only in that one point. And I'm going to make this one a little different color so that you can see it a little better. So again, we're just trying to draw little tangent lines that go through that one point only to the best of our ability today. Okay, our third example, we have the line y equals negative 2x, and we're going to try to be tangent at negative 1. And this one is actually going to be a special case. Okay, so this would be a line that goes through 0, 0 because the y-intercept is 0, with a slope of negative 2. So it's a negative slope, slightly steeper than perfectly diagonal. So I'm going to try to do this one with a inserted line. Okay, so we need a little bit steeper than regular diagonal. And I'll leave it blue. And so we'll say that that is our line. And it's fairly close anyway, because I don't have anything labeled on my x and y axis. So anyway, we want to be tangent to this line at the point where x equals negative 1. And we'll say negative 1's right here. There's our point. We want to be tangent to that point. So now I want you to think about what would happen if you try to put a line in and just touch that one point. Well, if you think about it, everything is in line on a line. It's right next to each other. So if I'm touching that point, I can't put a line and just touch that point. So this kind of almost feels like it goes against that definition of tangent, but for what we're going to be doing in calculus, it's not. So the line that we have that we're going to put in as a tangent line to that point is actually going to be on top of that other line, because in order to touch that point one time, then it's going to touch all the other points as well. It's got to be on top of it. So this is a special case. It feels like it defeats that definition of tangent, but for calculus we need it to match. We need it to follow that touching that point in one place rule, and that's how it works. Our next example, y equals e to the x at x equals 0. This is a good example for you to try if you want to pause and try to do this one on your own. Okay, you have to remember that e to the x is your exponential growth graph, and it looks something like this. Okay, and we are trying to be tangent at x equals 0, which would be this point on the graph right here. And this would be an easy one to draw in. So to work with it just a little bit, it'll be easier when you're trying to draw it by hand. So something like this would be a tangent line. It would go through that point, just touching it at one place. It falls under that exponential graph. So that kind of sketch is acceptable. Okay, example 5 is going to give us a little bit more of an interesting situation. We have y equals the square root of 4 minus x. And again, if you're thinking y equals the square root of x as your parent function, that shape some of you call the shooting star shape. Look at the shifts here. I can rewrite that as negative x plus 4. And so it's flipped horizontally, and it was moved left 4 and then flipped horizontally. So if we move a shooting star left 4 and then flip it horizontally, we'll be over here at regular 4 and making our shooting star pointing to the left. And so if you are questioning that, wanting to see that, make sure you type it in your calculator to verify what's going on. But we are wanting to do our tangent line at 4, which is right there on the end. And you have to remember that the square root function is part of a parabola that has been turned sideways, and we have to use part of it at a time so that it passes the vertical line test. So now I am going to try to draw the tangent line through that one point. And to go through that one point, it should draw straight up and down because of the way that it's a parabola turned sideways. And if you remember, our first example was a parabola, and at the top of the hill we had a flat line. So if you turn a parabola sideways at that vertex, you should have a vertical line because they should be opposites if they're flipped opposite ways. So this is where we would draw the tangent line in to this graph. Okay, for our last example, we are going to do another special case. This one is absolute value. It's moved right 3. So I'm going to say if this is 3 right here, I'm going to put in absolute value. So it'll look like something like this. The V shape's been moved right 3. Now, the thing about this one is at 3, there's actually many tangent lines that you could put in, and I'm going to put some in for you. So you can see I've drawn a whole bunch of tangent lines, and every one of those tangent lines goes through that point at 3 one time, and they don't affect the rest of the graph. So this is a special case. There's infinitely many tangent lines that can be drawn. So first of all, you need to mark this as a special case. And when there's infinitely many tangent lines that can be gone, that's usually happening at something like a sharp corner, and there's special things that we will be learning about that in future lessons. So make a note that if there's a sharp corner on a graph, you can draw infinitely many tangent lines. And I've just drawn a few, but obviously you could just keep drawing until you've filled up this space. One more thing that you may need to realize is if you have a vertical asymptote on a graph, there's no point. So if they give you a place to draw a tangent line, say draw it at 2, but there's a vertical asymptote at 2, you cannot draw a tangent line there. So make note of that. If there's a vertical asymptote at that x value, there are no tangent lines. Now, before that and after that, you can draw tangent lines, but at that particular x value, it's not possible. Also, if there's a hole, so I guess I'll put hole under here as well, you cannot draw tangent lines on that graph. And that concludes this lesson. Today you're just going to be practicing drawing tangent lines because they're very important to where we're going with this. So we just have to get used to drawing them.